Morning, Sarah and Mike.
Good morning.
Good morning.
Welcome, everyone. Thank you for joining us for our annual science report back to you. Friends of Casco Bay is dedicated to improving and protecting the health of Casco Bay. We do that by monitoring water quality and analyzing the data and using that to inform us where there may be problems, issues that we should pay more attention to and act to fix. So my name is Ivy Frignoca. I'm the Casco Baykeeper with Friends of Casco Bay. And with me are Mike Doan, our staff scientist, and Sara Freshley, our community organizer and volunteer coordinator. So bear with us because we're attempting to blend the conversational nature of the Coffee with Casco Bay series with a slide presentation about science. So we'll be using more slides than usual, but for a good reason. We'll focus on 4 aspects of our monitoring, 3 programs that we as a staff do, and then 1 program, Water Reporter, that all of you help us with. So in those programs, we will not be covering our PFAS monitoring. That we're only partway through that study. We don't have enough data back yet to report to you. And there will be an entire program dedicated to the PFAS monitoring program, probably early winter. So stay tuned. That is coming. Please put your questions in the chat, and we have reserved time at the end to answer questions. Also, Heather will be behind the scenes, and if there's a question that can just sort of like quickly be answered, for example, like, what does Mike mean by that term? Heather may answer that for you. So to practice and to let us know that you're as passionate about science as we are, could you answer the question in chat? What do you like most about science? Okay, Mike, while people are answering that question, where are you today?
This is my new lab. And as many of you know, we moved our office from South Portland to Portland across the bridge about a year ago now. And with that move, I got a new lab space. It's much bigger and brighter and more organized and efficient. And I'm excited to come here every single day. It's still exciting to me. It's like Christmas morning getting in here. So, and if I could, over my shoulder here on the bench, you may notice these are the multi-parameter monitoring instruments that we use in all the programs, all of the water quality monitoring programs that I'm talking about today. And that this instrument will come up often. It is the data sonde that we use, and you'll hear more.
Okay, so I know people have seen photos of you over the year holding those data sondes out in the field and collecting information. This is what it looks like back in the lab. This is where Mike keeps those sondes, and this is where he works on them to make sure that they are calibrated, which means that can collect accurate data.
Yep, exactly.
Let's start our presentation.
Sure. And when I was talking about data collection, we certainly use those data sondes, but data collection is very much a team effort here. It's not just me out in the water with those equipment collecting data. It's the entire program team, and you can see all of us here. And that doesn't only allow us to do more than certainly what I could do on my own, but it means we're getting better data, we're collecting data more efficiently. And beyond that, I really think that it allows us to be better in our individual roles. For example, Ivy, when you and Heather are out advocating for the Bay, you were part of the team collecting data that you're now talking about. And Sara Freshley, when you're out talking with water reporters, you were on the boat with us, and you can share what we're seeing on the water and then bring back experiences from your water reporters back to us. So I think it works in many ways, but it's great to have a more collaborative team effort. It's a great approach.
Yeah, so Mike, this slide is really interesting and gives a peek at some things that our members maybe have not seen before. So for example, you're holding a piece of equipment that we are just beginning to use more and more. So just quickly, can you tell them what that piece of equipment is? So when you talk about
Sure.
light availability later, it makes sense.
And that's exactly it. That's not a data sonde. That is
Yeah,
a light
thought y'all
polarizer.
might appreciate that.
It's a light sensor in simplest terms. It allows us to see how much light is getting through the water column. And that was a big part of our eelgrass work, and you'll hear about some of the results in just a bit, but we'll be including that in our seasonal work moving forward as well.
Okay, and also to give people sort of a different look, since they always see photos of you at the sonde, Heather has an instrument in her hand that she seems to be pouring water from. Can you talk a little bit about what that piece of equipment is and what that allows us to do?
Absolutely. That's a water sampler, so we can lower that down with the ends open down to a specific depth, and then close those doors and collect a sample of water from any depth that we can bring up, pour off, and send off to be analyzed for whatever it is that we're analyzing. But a water sample.
It's really wonderful because it allows us to take to determine water quality at the surface and at the bottom.
Exactly.
So just thought while this slide was up that was interesting. And then the other contrast is Sarah and I are while you and Heather in this particular photo are collecting like the technical data, Sarah and I are more recording the observational data that goes along with it. And so what I'm doing is at each site, we record the conditions, the tidal cycle, the weather, the wind, and other sort of general information so that we can compare it to the data. And that's so important to have the observational data or the sort of other things that go along with the scientific data. Okay, time to get on and talk about the monitoring. So let's look at a map.
Yep.
And Mike, let's start with our seasonal program.
Sure. And
can you give an overview of that program and the type of data we collect?
Absolutely. Yeah. And you'll see this slide come up as we change when we're talking from one program to the next. So we're going to start with that seasonal program, Ivy, as you mentioned. So on this map, focus on the blue dots. Those are our seasonal monitoring sites. We go out to each of those dots, each of those sites, once a month, May through October, and we collect data with a sonde, with that water sampler. We collect data from the surface down to the bottom through the water column, and there'll be an example of some of that later. This is our oldest program. We've been doing this for over 30 years now, 33 years. So we have a lot of data from this. The goal of this program is to go out and kind of spot check around the bay, go to those sites and see how healthy the bay is at that point in time. But that doesn't mean that we can't look at 30 years of that spot checking data and look at trends as well. And I'll note real quickly that we do get temperature, water temperature, salinity, dissolved oxygen, pH, chlorophyll, which is a measure of phytoplankton in the water. You'll hear about that in a bit. And turbidity. With the data sonde, we use that water sampler to get a bottle sample to send off for total nitrogen analysis. And of course, we have Secchi depth data and those ancillary data as well.
So, Mike, we have very observant members, and they might look at this slide and say, gosh, Mike, that looks like less seasonal sites than I recall from the past. Can you talk a little bit about the changes that you made to the seasonal program in 2024 and why?
We really wanted to make sure we were getting to sites that we could sample the water column. We weren't just going to do surface sampling anymore. We wanted, because things changed from the surface down to even just a 1 meter and 2 meters down. So we returned to sites where we could get the entire water column and where we were able to get in one day to all of these sites to really make it as consistent as possible. And there were some sites we just couldn't get to anymore. For example, there was a site in the Presumpscot off a float, a public landing there that no longer exists. We just can't get good data from there. But ultimately, it was the data itself. We looked at a statistical analysis of how different the data was over time from each site. And when there were similarities, consistencies between two sites that were close together, we would eliminate one of those. So this is our sites moving forward.
Okay. And one other question before we leave this map and look at some of the data. Why is it important to collect more than one piece of information on water quality? Like, why would you not just go out and just do temperature and not dissolved oxygen or something like that?
Right. Each measurement we collect tells a different story about the health of the bay. And it's really important to get a lot of different points of view, if you will, on what's happening in the bay. And you need all that data, all the different kinds of data. And a lot of them interact as well. So you can understand what one thing is doing, like dissolved oxygen, by looking at another measurement, like pH. They usually act together, basically. Now, I'll share a little bit about why that happens. But we need all of those measurements to really get a better idea for how healthy the bay is.
Excellent. All right, let's move on to the next slide. Mike, you mentioned that
Yep.
you've been collecting data for a long time. Can you use this slide to illustrate one of the benefits of collecting data over the long term?
Yep. And this is a great example of our ongoing work. This is still our seasonal monitoring data, of course, but this is the annual average of water temperature since we started collecting data through this program. So even though some years have averages that are a bit colder or a bit warmer, when you look at that red line, that trend through the data is going up. The water is getting warmer in Casco Bay. And only because we have that much data, we've been collecting data for this long, can we look at this. And the rate here is important. We go up about 1 degree Fahrenheit per decade, or over 3 degrees Fahrenheit. On average, we're 3 degrees Fahrenheit warmer than we were when we started collecting data. And that's a huge amount.
Wow. That must make it hard for animals and plants that live in the bay to adapt.
Exactly. Yeah, this is important because there's the things that live in the bay, the plants, the animals have a fairly narrow range of what they're comfortable with. And as our bay gets warmer, we may start to see certain animals shift to the north where it's still cold enough, or animals from the south to move up now to conditions that were more like where they were previously. So we are seeing that shift in species in Casco Bay because of temperature.
Right. And we're even suspecting that that may be one of the causes of why eelgrass isn't as abundant.
Absolutely.
So, Mike, you also mentioned that we use a seasonal program to get a snapshot of the bay at any given time, both to sort of like look at the overall health of the bay in a particular year, and then we can also sort of hone in on particular sites. Can you give an example of that from last summer?
Yes, I can. I'm glad you asked. So the real goal of this program is to get out there every year and just to see how healthy these sites are. And as you mentioned, we use a lot of different measurements to understand the health. The two biggest ones, I think, are dissolved oxygen, the amount of oxygen in the water, and pH, the acidity of the water. Those are two great indicators of the health. If you have low amounts of oxygen, then everything in the bay that needs oxygen to breathe, just like we need oxygen here on land, will begin to suffer. And if the bay becomes too acidic, things will be negatively impacted. So those are two great indicators of the health of the water. And last year, the data looked very good. I can say that the bay is generally very healthy. Most of the sites were where we'd expect for both the amount of oxygen in the water and the acidity of the water. So things are pretty good. There was one site that fell out toward the lower end of the scale, whether it was dissolved oxygen or pH, and that was in the Harrisicate. For some reason, that site was statistically different than every other site we get to through our seasonal work, had lower water quality than those other sites. And that's an area we'll be spending a little more time moving forward.
Yeah, Mike, you mentioned that the bay looked pretty good overall. It was interesting to me after sort of years of really unusually hot weather or drought conditions that the bay seemed a little bit more like typical or normal, like
Exactly.
sort of suggesting why trends are important, because if you just monitor in any particular year, you're not going to pick up the different things that are happening out there.
That's
Now,
exactly right.
when we looked at that sort of team slide in the beginning, we saw Heather with a instrument where she was collecting water from the bottom. And I know what part of what she's doing is collecting water samples to be analyzed for nitrogen. Can you talk about why we collect water samples to be analyzed for nitrogen and overall how the nitrogen levels were in the bay this summer?
I can. Nitrogen is a really big issue for us. Nitrogen pollution, I should say. Obviously, everything
Do you
needs
want the next
nitrogen.
slide up for you
Oh,
to
if I
do this?
could, sorry, yes. Yep. And the slide we're going to look at right now is a graph of the average total nitrogen concentrations at all of our sites. So we have some of the seasonal sites here, but we also have our continuous sites and our eelgrass sites because nitrogen is that important. We collect it every time we go out. And as I was just mentioning, nitrogen is a critical nutrient. We just don't want too much of it. Too much nitrogen can over fertilize the bay, just like it fertilizes your gardens and your lawns at home. Too much of it can stimulate algal blooms, and we'll talk about that in just a bit. But that's why we're concerned about it. What we saw in 2024 was that most of our sites were below that red line on this graph at 0.32 milligrams per liter of nitrogen. That's a general guideline that's been used in our region. If you get above that line, you may start to see some impacts. You probably will start to see some impacts. But even if you're approaching that line, but still below it, you can have some negative consequences as well. And a handful of our sites do fall out in having high enough nitrogen concentrations where we would be worried. Portland Harbor certainly shows up at that end of this graph. McCoy Bay, which we'll hear more about, is here. And of course, the Harrisika, which we've already mentioned, has some higher than we'd like nitrogen concentrations.
Yeah, so the Portland Harbor, we monitor from Fort Gorges all the way up to Portland Harbor to near where the South Portland wastewater treatment plant effluent discharges. So the pH 3 is on the sort of inner side of the harbor, closer to, or the Fore River, closer to the discharge site, correct?
It is, and actually above that, yeah, well up the Fore River. And you can see that there's a lot of variability around that. It generally was okay, but it had a couple of times, a couple of monitoring dates where we had higher nitrogen concentrations than we'd like to see. And that pulled that average up.
And in case, these are all codes that we use out in the field. So the other site that's kind of high, the RRC, that's at the mouth of the Royal River.
Correct.
Okay.
Yeah, I'm
Now,
sorry. If there are any questions about site codes or where we monitor specifically, I'd certainly be
add
happy.
them in chat because those are the kind of questions Heather can answer as we're going along if you want,
Exactly.
if you need any interpretation on the slides. Now,
Yep.
you mentioned that we do this because it has impacts on the health of the bay. And so, Sarah, you have been patiently waiting to join our conversation. I want to give a big shout out to Heather. To Sarah. She really evolved the water reporter program in 2024. So before you talk to us about the observational data that shows some of the impacts of high nitrogen loading to the bay, can you talk about what you did to the water reporter program in 2024?
Yeah, thanks, Ivy. We're about a year into a brand new water reporter app that we at Friends of Casco Bay developed ourselves. So we were able to customize it to the issues that we prioritize here at Friends of Casco Bay. It's also much easier to use, which many of you who use the old app had have told me, which is amazing. So the idea is that it's really easy to use out in the field really quickly. It also gives us better data and allows us to analyze that data in a much more complete way on the back end, which we're really excited for.
Okay, so I want you to go on and talk about the nitrogen piece. So maybe we can move on to the next slide.
Yeah, definitely. So as Mike was explaining, too much nitrogen pollution can have many impacts on the bay. I'm going to talk about just a couple of them in ways that water reporters really help us track this. So one way that too much nitrogen pollution can impact the bay is through nuisance algal blooms, which you see here. So this is where there's so much nitrogen, it's a fertilizer. These algal blooms just explode and they get so thick, as you can see at the picture on the right, that they actually smother the clam flats and they can deplete all of the oxygen in the mud and kill the organisms that live there. And water reporters really help us at low tide. They go out all throughout the bay and track these algal blooms because we never know where they're going to pop up or how long they're going to last for. So water reporters, help us be the eyes of the bay and track that for us. And then we have a record over time of those algal blooms, and we can look for patterns. Another way that too much nitrogen can impact the bay is...
I know, hold on one second, Sarah. I know you're going to go on
Yeah.
and talk about, like, this is the macro algal bloom, the ones we
Yeah.
can see with our eyes. I know you're going to go on and talk about that on the next slide, but before we transition to the next slide and you talk about that, one of the things I think is so great about this slide and the differences between what two different water reporters have captured is on the photo on the left, the bloom is still not thick enough to just sort of stay on the bottom. It looks like it's still rising and falling with the water. And it's when it gets so thick and so heavy that we watch the tide come in and it just stays on the bottom, that it has that real smothering effect. So these photos are really important because they help us to track a bloom over time. And so we're so grateful when some of you volunteer to keep going back to a particular site and helping us track the evolution of a bloom from when it starts to when it dies back in the fall. So now on to the next slide and your next topic of water reporters.
Yeah, so algae that we saw on the last slide is a macro algae, right? Phytoplankton is a microalgae, so it is much smaller and it blooms as well. So these photos of brown water are an example of when phytoplankton blooms in the water column, throughout the water column. It doesn't sink to the bottom in the same way that the nuisance algal blooms do, but it turns the water brown, which is very clear in these photos. A lot of the times every summer, we get someone reporting on Water Reporter, or, when we're out in the field and talking to people, people say, the water is so brown, what's going on? And so that is likely a phytoplankton bloom, which often occurs because there is too much nitrogen pollution in the water. And this is one way that water reporters really help supplement our scientific data. And it's a way where the scientific data and the water reporter data really overlap. And I'm going to hand it back to Mike to talk about ways that not only are we seeing these blooms with our eyes, but we're also seeing them in our data.
Okay, one second. Before you turn it back to Mike, I just had a thought, as I often do. You guys know from working with me. This brown water, when we say, like, you'll see it when there's a bloom, it's really important that you report these observations, because sometimes it's like a good thing, right? It's just a combination of these tiny microscopic plants that help feed the bay and are an important part of the food chains. Other times there's a species that showed up in Casco Bay, I think it was in 2017, called Karenia mikimotoi, that looks like this. And it's very toxic, and it depletes the oxygen, especially at depth, and affects lobsters that are in traps. So these observations, when you report something like this, we share that information with the Department of Marine Resources so that they can go out and test these blooms. So your observations are not only important to us, but to the state. And sometimes the Department of Marine Resources will ask us to collect observational data if they're trying to track what is occurring in Casco Bay. So now back to you, Mike.
Sure. And I just want to quickly point out that these phytoplankton are single-celled. They're microscopic plants, if you will. And for enough of them to change the color of the water like this means there's an awful lot of phytoplankton out there. And what I want to talk about with the next slide is how a large phytoplankton bloom can affect the water quality. And we've talked about dissolved oxygen and pH as being indicators of health. I want to talk about that in a second, but bear with me here. I really love these slides. All of these are going to be from our seasonal monitoring site in McCoy Bay, which is kind of off Brunswick and a little above Freeport. And you'll see July 2024 data on the left and August 2024 data a month later on the right. What you're looking at is a slice of the water column. When I said we go out, we lower that data sonde from the surface down through the water column. That's the data you're seeing here. So on the very left of these graphs, you'll see 0 at the top and then down to 9 meters deep at the bottom. So it really is the water column. You're looking from the top to the bottom. And what you're seeing in July is a large phytoplankton bloom. We use chlorophyll as a measurement. Chlorophyll is that pigment found in phytoplankton, all green plants. What we expect to see for chlorophyll when we go out monitoring water quality is somewhere between 0 and 5 micrograms per liter. That's a good, healthy background amount of phytoplankton. That's enough to fuel that food web. What we don't want to see are concentrations getting up into the 20s, like we're seeing here in July. So evidence of a very large bloom, well above what we normally see, but is unfortunately evident in McCoy Bay more frequently than we would like. So a month later, we see that the numbers, the bloom, the chlorophyll numbers are now much lower, back into that 0 to 5 range. So the bloom has gone, but it's not forgotten. The cells, the phytoplankton, have died and sunk to the bottom and are going through the process of decomposition. And that process is what causes our problems with the health of the bay. So if we go to the next slide, we can look and see what happens as that large bloom dies out and decomposes at depth. So again, looking at July, during the bloom, we see oxygen levels, and this is expressed as a percent of what could be in the water. Water can only hold so much oxygen depending on the temperature and salinity to some extent. This is supersaturated water as far as oxygen goes. We have 140% oxygen at the surface. This can happen. It does happen when you see a large phytoplankton bloom. All those phytoplankton are going through photosynthesis, producing oxygen, and that's what you're seeing in the water. That's what our instruments pick up. Fast forward a month to August, the bloom is decomposing on the bottom now, or much of it anyway, and you can see how it's pulling oxygen out of the water. We start up around 110% at the surface, but as you go down through the water column, you get down below 85% saturation. And that's a big difference. And it's because the bacteria responsible for the decomposition of all that organic matter pull oxygen out of the water. And that's what you're seeing here. And I'll just leave this slide with a quick note that 85% saturation is a state criteria for SB waters, which is where McCoy Bay is. And below that is, I guess you'll say, in violation of that standard. We have low enough oxygen that we're below the state standard. So
yeah, and that standard is set. I know we should move on to the next slide, but that standard is set because that's what the science says is important to support marine life.
Exactly.
All right, let's go on to your next slide.
Don't have enough of it at the depth there. So the last one I have in this series, again, we're looking at the water column. So surface to bottom here. We're looking at pH now and measure the acidity. We had very good acidity levels in July during that bloom because as that bloom is, again, going through photosynthesis, they're adding oxygen, but they're also pulling carbon dioxide out of the water, and that allows the pH to be higher. These are pretty high numbers for summertime. They're very healthy numbers on the left in July. After that bloom, though, the reason we worry about these blooms is because all of that decomposing organic matter increases the acidity. It's lowering the pH, but that means there's more acidic water, especially at depth. And it's because, again, as those bacteria are breaking down that organic matter from that bloom, they are adding carbon dioxide to the water through that process. Anytime you add carbon dioxide to the water, it becomes more acidic. And that's exactly what we're seeing here. And that's a huge swing from that 8.05 at the surface to 7.85 pH at depth. That represents, it's on a logarithmic scale, of course, it represents a huge drop in pH, a huge increase in acidity. So that's just a quick example of how nitrogen can grow a large bloom, which can impact the water quality.
Yes. So, and we're going to move on to our next type of monitoring. But before we do, when Mike was talking about a healthy pH, for Casco Bay, healthy is about 8 on this logarithmic pH scale. And because it's logarithmic, every change is like a tenfold change, right? It's not like simple subtraction or addition.
Correct. Yes. Yes.
So
that's a big difference.
It's a big difference, and it's a big difference in a short amount of time. So if you're an organism living on the bottom, this is it's a fluctuation to deal with. Mike, we have about 15 minutes left, so let's go on to our back to the map and talk a bit about the eelgrass pilot study that we're halfway through. Can you orient our members on this map to those sites?
Absolutely. We are part of a large collaborative effort to study why we're losing so much eelgrass. Eelgrass is a critical marine habitat for a number of reasons. And unfortunately, the last time it was mapped a few years ago now, we saw that we had lost over half of the eelgrass in Casco Bay. So it's a really big concern of ours and others in the region. We are part of this team to study why we're losing eelgrass. We're looking at the stressors involved in water quality. Others are looking at stressors like green crab predation, that sort of thing. Our role is to go to these 3 green dots on the map. Those are our eelgrass sites. Mackworth Island, Broad Cove, and there is a green dot behind the gold star. I can't really point. You can't see me point, but behind yes, thank you, off Cousins Island. Those 3 sites are the outer edge, the deeper edge of eelgrass beds. We went there 6 times over the summer and looked at water quality and light availability. Eelgrass needs temperatures that aren't too high. It needs low nitrogen for reasons we just discussed, and it needs a lot of light. So the one slide I want to share is from the light data we're collecting, and I can do this pretty quickly. This is just a measure of the amount of light at depth for the eelgrass. And we want to be below that red line. The red line's a guideline for not enough light in the water. If you get above that line, then you're not seeing enough light to support healthy adult mature eelgrass beds. We are below that line, so conditions were okay, we're good, but we're close to that line, and we might be close enough that it might interact with warming temperatures and cause trouble, but there was no real serious red flags so far. We will be doing this again, as Ivy mentioned. We just did year 1 of a multi-year program, so we'll be out there again collecting more data, and I'm sure in the future we'll come back with a more complete picture, perhaps. But it's something we're definitely involved in.
Yeah, and our just as a couple side notes, when you saw Mike in the team slide with that instrument over the side, that's the Lycor that he's using to collect this data.
Right.
And our partners are focusing on other aspects, like there's a dive team that's collecting seeds and looking at the health. There's another team that's studying green crab presence and absence. I won't go into it all right now, but the study will be done by the end of next year, and we can give you a much more complete report. The most exciting part, or what I think is of this study to date, is the role that water reporters are playing, and everyone is paying attention to that role, not just in the pilot project, but in some of the broader networks like the Blue Carbon Network and the Seagrass Consortium that are coast-wide scientists working on these issues that we're dealing with. So, Sara, please share with us the amazing work our water reporters are doing.
Yeah, eelgrass is a pretty hard thing to study because most of the time it lives underwater. And as Mike said, the Maine Department of Environmental Protection does map all of the eelgrass beds in Casco Bay every 5 years. They're very thorough about it, and it gives us a lot of helpful data. However, in between those mapping cycles, a lot can happen. This is a dynamic ecosystem. A lot can even happen from season to season, from month to month. And so water reporters really help supplement the data that Mike and our other partners are taking, as well as DEP. So in the next slide, you can see some of the ways that water reporters are helping us. So water reporter Ann Wood has been water reporting with us for years, and you can see how helpful this is. This is at Town Landing in Falmouth Town Landing. And on the left is an eelgrass bed that she took in 2020. And on the right is that the exact same view, which we can see from the dock. There's hardly any eelgrass left. And this is something that's in between mapping cycles. This is not a bed that we're studying with our science team here at Friends of Casco Bay. And so water reporters really help fill in some of the gaps and track the eelgrass beds from, a week to week, season to season basis. So eelgrass beds are exposed at really low tides. These really low tides happen a handful of times a year. So while it lives underwater most of the time, it can be exposed, which is an example in this photo. So in September, we had water reporters go out all throughout Casco Bay because there was one of those really low tides over the course of about 3 days. And I'll show you that in the next slide. So while we are seeing a lot of depletion in the eelgrass beds, through what we called the seagrass snapshot in September, we did find a new bed as well. So let me just orient you to this map. In the top right is the southern edge of Mackworth Island. In the bottom left of the map is the Eastern Prom in Portland. The pink in the map is the map that DEP mapped of eelgrass in 2022. So that's a really large bed. It covers a large area. But in the seagrass snapshot, we did not see any eelgrass on the southern end of Mackworth where that pink area is. That doesn't mean that there's no eelgrass there. These observations don't give us a conclusion of whether there's eelgrass there or not. But at that time, we did not see any eelgrass. Meanwhile, in the bottom left, where those green dots are, we found a new bed thanks to a water reporter that was kayaking and saw eelgrass. We ventured out at low tide across the mudflats, and this bed here, as you can see on the left, is a really healthy, dense bed. There's lots of snails growing on it, and it's really exciting because I don't know if we would have discovered this bed before the DEP maps in their next cycle. So now the next time that there's a really low tide, we're tracking this bed, and these photos help us track these changes over time. It's really valuable information.
Yeah, and I know we have to switch back to Mike and talk about continuous monitoring. But the other thing I love about this and the fact that water reporters are finding new patches of eelgrass is it really gives us hope. You know, it's very sad when we think about eelgrass disappearing and the changes that are coming, and to know that it's has the capacity, and we might need to assist it in ways, but it, you know, that it is coming back is really a hopeful sign. So Mike, back to you, and looking at the map again, if we could, to talk about our the final monitoring program that we're going to highlight today. You really were the big driver behind us switching to continuous monitoring. Can you talk about why you felt it was important that we switch to continuous monitoring and what it is?
Absolutely. Yep. And we're going to look at this map for those 3 gold stars now. Those are our 3 continuous monitoring stations. And the site in the middle off Cousins Island has been here for 9 years now. So it's starting to become a greater data set. The one to the left in Portland Harbor and the right in Harpswell are only 4 years old, so they're newer. But we added this continuous work because we weren't seeing enough of the changes in the bay. There's a lot of variability, a lot of things that happen more than just once a month when we're out there for the seasonal work. We really wanted to understand the bay better and able to really understand how it's changing over time. We're also getting a lot more acidification data through this effort. What we do is leave that same data sonde that you see behind me that we've used for the seasonal work, for the eelgrass monitoring, we leave that in the water. It is set to collect data every 15 minutes year round. So it really is a lot more data, and it really helps us to better understand how the bay functions and how it's changing. And on the next slide, you'll see what it looks like. It really is just a simple cage with a data sonde enclosed. It's the sonde is fixed to a shelf at the top of that cage. It's a modified lobster trap. We leave it set on the bottom, attached by that line. This is our Portland Harbor station here. And the line is attached to that float. So it's a very simple setup, but it gives us an awful lot of really important data.
Yeah, and Mike, again, for our sharp audience, because I know they are, they may remember that when you originally set up this station, you had the data sonde in there and another instrument that was measuring the partial pressure of carbon dioxide. And that's missing, but you're doing something else in this photo. Can you talk about why you transitioned from that piece of equipment to what else you're doing?
Yep, we've always collected good data. We want to improve the accuracy as much as we can, because a lot of those acidification parameters need to be calculated. And the more accurate the data, the better those calculated values are. So on the side here, we're taking water samples. Of course, we take water samples for total nitrogen, as you've heard, but we also collect water samples every time we go to swap out these cages. Every few weeks, we collect bottle samples that we ship to the University of New Hampshire, where they analyze it for pH and total alkalinity, which is another acidification parameter. And by collecting these bottle samples, that gives us the real gold standard, I guess, to see how well our sonde is stacking up against those results. So it allows us to improve the data we're seeing through the sonde.
Okay, so and you've been collecting some of this data now for 9 years. So can we go on to the next year, and can you share a little about trends that, I know it's not 30 years of data yet, but trends that you're beginning to tease out?
Sure. What it really allows us to do so far, and we'll get there to when we can start talking about real trends, but so far we can compare year to year. And I want to talk about temperature first, and this is temperature data from our station in Yarmouth. And what you're looking at is just a little bit of data. On the left is the data, the temperature data in daily averages, January 1, 2024 through late February 2024. The graph on the right is still at Yarmouth, still water temperature, but it's January 1st through late February 2025. So this winter we're just coming out of. And I just want to simply compare 2024 to 2025. What you're looking at here is the gray shaded area represents the historic range of data. So we can compare the 2024 data to data collected in prior years. The gray line through the middle is the average of all that historic data. The blue line represents the 2024 data. And as you can see, that line is toward the top of that shaded area. So we had a warmer winter, at least that period of time, than we had on average. Moving to the right to 2025, that blue line for the data we collected in 2025 is below the average, a much colder winter this past winter than we've seen previously. And I know you may be able to just walk outside. You probably could have figured that out. And we've got some great images of frozen green crabs from this past winter, that sort of thing, which is great news. But just one of the things we can start to do with this continuous data, compare year to year.
And just to note, it was one of our water reporters who got that photo of the frozen green crab, and it's not often that we champion, yay, there's a dead crab. But given the destructive role that this invasive species has played, that's an encouraging sign. Mike, let's hone in on last summer, because I know we also use this to get that snapshot in time like we do with the seasonal program. So let's go on to the next slide.
And so year by year, now we're looking at a graph of data from Portland, our continuous site in Portland, and we're looking at the entire year in 2024. So across the bottom, you're moving through time, January through December. It's again, daily averages. Again, the gray area is the historic average, and that average is right where you'd expect it for Casco Bay. For salinity, we're looking at salinity now, a measure of how salty the bay is. And that average is right around 30 parts per thousand. That's what you'd expect. We had so much rain last spring, late winter, spring, early summer, that it really lowered the salinity in the bay, made the bay a little bit fresher because of all of that water running off land. And as you move to the right of the graph into the fall and winter, that blue line is above that historic average. So we had higher salinities because of the drought we had. So what the effects we're seeing on land certainly impact the bay, and we can see that in the continuous data. And the last quick thing I'll mention, the photo inset here is of from the top of East End, looking out over the Presumpscot River plume that's discolored because of all of that water coming off land. Isn't just nice, pure, fresh water, of course, is carrying with it nitrogen, bacteria, toxins, sediment that colors the water the way we're seeing the colored water here. So it's something we're certainly tracking. But that's a great example of looking at 1 year and seeing what we experienced.
Yeah, Mike, let's go on to the final slide.
Yes.
We had talked a little bit about the transition that you're making to get very accurate data so you can calculate the impacts of ocean acidification on the health of the bay. And this slide represents one of those calculated parameters. Can you explain why you calculate omega aragonite and what this slide depicts?
Yep. So first, it's a look at 2024, January through December. We're looking at omega aragonite, which is simply a way of expressing how much calcium carbonate is in the water. It's one of the ways we look at acidification. Why is this important, this particular measurement? Shellfish require calcium carbonate to build their shells. So the mussels, the oysters, the clams all need, their shells are made of calcium carbonate. That's why this is important. So what we're concerned about is that we have omega aragonite or calcium carbonate levels below this guideline, this red line at 1.5. If you're below that, it's harder for those shellfish to build their shells. And so we want to see more data above that line. I will point out there's no historic data here. This is all 2024. Each of those three colors represents a different one of those three sites: dark blue for Portland, light blue for Harpswell, and green for Yarmouth. And the takeaway here too is that Portland Harbor has lower amounts of this saturation of calcium carbonate than the other two sites, and which you'd expect in an urban area with a lot of runoff, a lot of organic matter. But that's what we're seeing here. If you get too far below that line, it's much harder for shellfish to build shell. There's a lot of other impacts as well, but this is one biologically important measure of acidification that we're doing a better job calculating.
Yeah, and as we transition to going to audience questions, I just want to mention that I sit on the Coastal Marine Working Group of the State Climate Council, and the Science and Technical Subcommittee of the Climate Council, which has sort of the top scientists working on these issues, and they review the best available literature. That's how we set the 1.5 as the level. That's the best available science recommendation right now. And they have modeled that if we stay at a high emission scenario, if we're not able to reduce our impact by 2050, we're talking only 25 years away, omega aragonite will never go above that 1.5 threshold, which will make it very hard for Maine's shell fisheries. So now it's time for questions from the audience. So let me pull those up. Mike, this first question goes to you. How does Casco Bay's 1 degree temperature increase over the last decade compare to the Gulf of Maine's temperature increase?
Sure, those our data is in line with other data from around the region. That's very similar to what others see for increase in temperature, about 1 degree Fahrenheit per decade. We're right in line with what others are seeing, which is really unnerving.
Which is really unnerving because the Gulf of Maine is warming faster than 99% of the ocean's waters.
Thank you. Yes. Yep.
Okay. I'm going to ask the next question to Sarah, but Mike, feel free to join even if you want. We have a question about, what does eelgrass look like? Some people think they saw rockweed in the photo off East End, not eelgrass.
Yeah, so how I explain eelgrass is it looks like cooked pesto fettuccine. It's limp, it's it's straight all the way across, whereas salt marsh grass or rockweed, salt marsh grass comes to a point. Rockweed often has what I like to call sea beans. They have these little bean-like things along the strands, and eelgrass really is just straight all the way through, green, limp when it's out of the water. But underwater, it does, of course, stand up straight and looks like a meadow.
That's a very artistic and creative description. Mike, can you talk about the difference between algae and a plant and what might be some of the other differences?
Sure. I was going to say there was some rockweed in that image in the foreground. And the eelgrass was out beyond the rockweed that was there. So whoever caught that, you're
so
absolutely
astute.
right.
Yes.
Yes. But beyond that, and it is, the eelgrass is one of the only true flowering plants with a root rhizome system, as opposed to the seaweeds, which are algae. If we had an image, we could show the difference. But I think the thing to remember here is that eelgrass is a flowering plant, for lack of a better description, and it is like a cooked pesto, I guess.
I never thought of it. Thank you, Sarah.
And you're Italian, Ivy.
I know. Oh, Mike, what is the salinity data for Cousins Island compared to Portland Harbor? And it's either more impacted by freshwater inputs?
Yes, the answer is yes to both, actually. there's something really odd about the Portland Harbor site. There's a lot of offshore water that ends up in there in the summer, based on the circulation, I would imagine. That keeps it a little colder and a little saltier than the Yarmouth site. Yarmouth site is more exposed, I think, to open water. So it's interesting looking at that data. I'll just put a quick plug in. If you go to our website and look under the continuous data, you can compare Portland to Yarmouth and to Harpswell as well. For all the parameters we've mentioned, that data is there. So you can see how they compare. I can't bring it up now, of course, but that's a great place to check on those things. But when you look at the summer versus winter salinity in Portland Harbor when compared to other sites. There is a really interesting difference going on there. And it's a reason we collect this data to see how these sites are different.
Okay, next question, which I'm not sure we can answer, but it's been a cold winter. Has there been an impact on green crabs? So we mentioned the frozen green crabs. Sarah, any other observations from water reporters?
Not yet, no. I think that we will see impacts this summer, and we'll learn a lot more as science from us and other organizations are conducted this summer to see what the impacts are of this really cold winter. We're all anticipating.
Yes, we know at least one green crab.
Yeah, we know one green crab was frozen. But water reporters, if you do have photos of frozen green crabs, please upload them. It's not too late because we would love to see that.
We should make a calendar.
Mike, going to you. I know in talking with Dr. Brian Beal from Down East Institute, and he's been studying green crabs for quite a while. He has said that when the temperatures get below freezing, that impacts all the eggs that the female green crabs are carrying over the winter and causes them to die back because they produce a ton of eggs. And so I don't know if I don't think anybody could answer that question yet, but we'll certainly be looking and hoping that the winter had a negative impact and there'll be less baby green crabs. Anything you want to add?
Yep, just quickly. It is, since we are we'll be moving to the second year of that eelgrass collaborative effort, there are other organizations looking at green crabs specifically. So we'll know from their accounts if there's been a measurable impact. I don't know if we can trace it back to the cold winter, but I will also add that the green crabs have been here as an invasive species for over 150 years now. But it really wasn't that big a problem when we had colder winters like we just had, although it really wasn't even that cold this winter when you look back in time. But those cold winters do knock back the numbers. So it is hopeful that we're seeing fewer green crabs coming up. We'll see.
Okay, I'm going to do a couple more questions. Well, maybe two more questions. So the first is, what is the impact of cruise ship scrubber wash water discharge to the bay on eelgrass? And before answering that, I mean, from the science perspective, there are no eelgrass beds near Ocean Gateway. I mean, the closest one is probably East End.
Yeah, it's a tough one to answer. I was going to ask if you had any thoughts on that.
Yeah. So right now, there has been no study in Portland, Maine of the discharge from open loop scrubber systems into the harbor. So the only data that we have that's somewhat related is our PH1 site that is sort of near Ocean Gateway. We're not picking up an acidification signal there that the discharge is making the water more acidic. And when I look at the study, which I have not read in detail yet, from Seattle, I don't see anything in there that I know has a direct impact on eelgrass, but I think this is an interesting question that we don't know the answer to. And I was concerned about other things like the metals being discharged or what is making the water more acidic. I was focused on other factors in terms of evaluating this cruise ship, any impact that the cruise ship discharge should have. So I guess what I would say is it's an issue that we are looking at and beginning to understand, or beginning to try to understand, and what we might need to do about it. Mike or Sarah, anything you want to add to that?
I'd say we're out there collecting data, and if we can see a signal, we'll certainly let you know. But we're out there monitoring.
Okay, Mike, final question. And if there's time, we can ask this for Water Reporter too. But Mike, what's next for the science program?
So for the continuous monitoring program, I can say that we will be adding telemetry to one of our sites this summer, which will allow you to see data live as it happens. And we'll be obviously sharing a lot more information about that with you. But I'm really excited. Sure, it's the image on the far right here is an example of someone else's, the Wells National Estuarine Research Reserve, actually, telemetry system. We'll be setting up something like this at our, I believe, our Harpswell site, hopefully. And this will allow you to log on and watch the data change over time.
That's
So
really
really
exciting. So
exciting
that means we'll be able to see the data in real time,
as it happens.
and
Yep.
you'll be waking up at 3 a.m. and eagerly peeking at your phone to see what's going on, right?
Absolutely. Yep. Is everything still safe and working? That's
Okay. And just quickly, Sarah, do you have any thoughts about where Water Reporter might go?
Yeah, we will be doing 2 more seagrass snapshots this year. So keep a lookout for an email if you are already a water reporter to be involved in that. And if you're not a water reporter, please sign up. We have an upcoming event to learn more at Prince Memorial Library on Saturday, the 29th, and you can find more information about that on our website.
Fantastic. All right. So as we wrap up, Mike, you are basically another long-term monitoring trend at Friends of Casco Bay. You've been here doing this work for 25 years. And if you had to summarize the goal of our monitoring program in a sentence, what would you say?
right. Well, I certainly feel like a long-term monitoring trend at this point. I think the message I would send is this, that, we're here doing this work. We've been here for over 30 years, and we're going to continue collecting data so we can act to protect the health of Casco Bay.
Excellent. That's right. We're here, we collect data to inform how we should act to protect the Bay. And we're here thanks to all of you. So thank you so
Absolutely.
much for supporting our work through your contributions and your volunteer hours. And a really special shout out to our water reporters. We could not do this work without all of you. So thank you so much for joining us. Want to keep this program on time and respect your time. So have a great day, everyone.
Bye. Thank you.
Thank you.
Bye, everyone.